We're going to start out by talking about the domain of a function. And I was thinking as I was preparing for this that I kind of liken it to a microwave. Now with a microwave, there's things you shouldn't put in, right? I mean, mostly you put in anything, but there's a few things you shouldn't put into a microwave. What would those things be? What don't you put into a microwave? Yeah, aluminum foil, basically metal, certain plastics. So there's things you don't put into the microwave. And in a similar way, when we have expressions, there are certain values of x that you don't put into an expression. So for instance, and I might actually have the problem number wrong itself, but let's go with this expression, x squared minus x minus 2 over x squared minus 1. Now the problem that you can run into here is a division by 0. You can't divide by 0. So certain values of x will create a 0 in the denominator. So what are they? Well, I'm not worried about the numerator, but I am about the denominator. So let me factor that. And when I factor that, ooh, I got a new subscriber. Ooh, thank you. Cool. So when I factor that, what do I get? Well, I get x minus 1 times x plus 1. But hopefully that makes it easier to see where the denominator could be 0. What values of x that I could put in here would make the denominator equal to 0? Good, 1 and minus 1. So our domain is everything but 1 and minus 1. X can't equal 1, nor can x equal negative 1. Now, if you look at that on a number line, it would look like this. So negative 1 to 1. These are the values that I want to miss. I want to avoid those. So here and here. Now, another way to write this, an equivalent way to write this, is with interval notation. So the interval notation would be negative infinity to negative 1 and a parenthesis. Why a parenthesis? Why not a bracket? Yeah. Parenthesis doesn't include that negative 1, negative 1 to 1, and 1 to infinity. So I could write it that way, or I could write the domain and kind of like say, well, this is what you can put in. Negative infinity to negative 1, union, negative 1 to 1, union, 1 to infinity. So a couple different ways to write it. Hopefully you're comfortable with the interval notation here. It is something that's going to be used a fair amount. So, all right. There's kind of a nice little warm-up example. Now, just like our microwave example, there's more than one thing that we have to concern ourselves about what we put into our functions. But before I get there, are we okay with this first example? Thumbs up on that one? Yes? All right, thank you. Let's try another one. And we're going to kind of do this one in sort of two parts. The first part is going to look like this. Example, square root of x minus 1. Now, what could go wrong with a square root? What thing might we be concerned with radicals? Yeah, exactly. We don't want negatives underneath the radical. All right, that's something we're going to cover in section 1.6. But for now, we want to make sure that this is at least 0, if not positive. So our concern is that x minus 1 is greater than or equal to 0. Hopefully you can solve that one pretty quickly. That means x is greater than or equal to 1. So that's your domain. Is x is greater than or equal to 1. If you're to graph this, how would the graph look? Anyone know? All right, so open circle or solid? Solid. Arrow to the right or left? Good, to the right. In terms of interval notation, it'd be 1 to infinity, Infinity always gets a parenthesis, but what am I going to put around the 1? Well done, bracket. Thank you. So a bracket there, and there's your interval notation, or you can write it with an inequality. Either way, you're all set as far as your domain is concerned. Now, let me rewrite this as a different example, which adds one more concern to our list. So for the first example here that we see, our concern was that this had to be greater than 0, because we didn't want to have a negative number underneath here. What's the additional concern that I get with this one down here? Yeah, it can't be 0. You can't divide by 0, so it's no longer good enough just to say, all right, well, x minus 1 has to be greater than or equal to 0. It has to simply be greater than 0, because I don't want a 0 in the denominator. So that changes things up. X has to be greater than 1, hollow dot, and this time an open parenthesis instead of a bracket. So a little bit different in terms of the domain, but here's your domain. X is greater than 1 or 1 to infinity. So a couple examples to kind of start with there. How are we looking on those first couple examples? Any concerns? Something you want to slow me down with? Feel free to raise a hand. Okay. Let me let you try one, and as you try one, I'm going to walk around and start learning some names. So let's go with this one. Square root of 2x over x plus 1. So a couple concerns with this one, and you have to kind of consider both of them as you work this problem. And as I walk around, let me teach you about my low-tech pause button, which actually I don't have a pause button. So as you're watching the videos, that means it's paused. All right, so just fast forward until you get past this point when I pick that up, and you should be good. But as I walk around, I try and learn your names, and if you have a nickname that you prefer to be addressed by in this class, let me know. Probably not going to get all the way around this first try. Okay, so there's two concerns with this problem. What's the concern down here? That it equals 0, right? So x can't equal -1, otherwise that'd be 0. But how about the numerator? Is there any concern up there? Yeah, this can't be negative. 2x has to be greater than or equal to 0. And that means x has to be greater than or equal to 0. So you've got both of these two concerns. Now, if you were to graph these things, you see that they don't really overlap. So x is greater than or equal to 0. Put a 0 here, solid dot, everything to the right. -1 is here. But because of the radical in the numerator, it's telling you that your domain, at least of the numerator, has to be x is greater than or equal to 0. So that kind of excludes -1, right? So we don't have to worry about this as long as we're paying attention to this. We're not going to use x equal -1 if x is restricted to be everything greater than or equal to 0. Interval notation for that would be 0 to infinity, like that. So are we okay with this one? Are we getting kind of the rough idea? The two main things right now to keep in mind are to look out for 0 or negative numbers underneath the radical and dividing by 0. Later on, we'll also worry about the log of a negative number, but that's not going to be quite on our radar just yet. Now, I did something for my morning class and for my class in general right now that I usually don't do, but I thought it'd be a good idea to do a factoring review because it's been like, gosh, a couple weeks since you've had an exam in Math 1150. So it might not be a bad idea to take a look at a factoring review. And let me pass you out a copy of this as well. Still got it from last semester? I've actually tweaked it a little bit, so I don't know if this is going to be the same or not, but I got an extra copy, so you're free to take one.
I took 1150 when I was drowning in culture shock and didn't know the word syllabus. I think I retained that.
Okay, that's good. Back in, right? Unplugged.
Oh, not a visible tattoo. You have a good memory.
Well,
but
it's
box fan.
box fan. Yeah, okay. Yeah, box fan. Thank you. Yeah, it was unplugged. Because that was the way you felt after the hurricane, right?
Something like that, yeah.
All right. Demetrius, send this over to
Really gorgeous antique I found that I couldn't use. People kept giving me generators from that guy.
Too funny. Okay, so in factoring, factoring is just going to be a big part of this section. So let's try and at least review a little bit of it before we jump into the section itself in terms of some of the problems with rational expressions. As far as factoring is concerned, the first thing you should always do is always factor out the GCF, assuming that there is one. If there's not one, hey, no big deal. But if there's a GCF, start by factoring that one out. After that, it's going to depend on how many terms that you have. If you have something to factor that has 4 terms, well, that one's a pretty easy choice. If you have 4 terms, assuming that you factored out any GCF, then factor by grouping. If you have something with 3 terms, well, then it becomes a little bit more interesting. You have a couple choices. Are those 3 terms the difference of squares? Or, not the difference of squares. Do those 3 terms have a leading coefficient of 1? Something like x squared minus x minus 12? Or do they have a leading coefficient of something other than 1? Like 2y squared plus 7y plus 3. So it makes a difference. Is that leading coefficient a 1 or something else than a 1? And there's a lot of extra work in factoring something like this. An example of which is below. We'll cover that in a little bit. But this one's pretty easy. You just find two numbers that multiply to negative 12 and add to negative 1. Minus 4 and plus 3. Notice that these have to have opposite signs because the last number is negative. Negative times a positive is negative. They can't have the same sign. The larger of these two has to have this sign in the middle. What if you have two terms? Well, this one's the busiest of all your choices. If you have two terms, then you have to decide, are you adding or subtracting cubes or squares? So if you're dealing with squares, that puts you down this path. If you're dealing with cubes, that puts you down this path. So, all right, great. We got two different paths to choose. Going down the squares branch, you could have the difference of squares or the sum of squares. And likewise, the difference of cubes or the sum of cubes. Just kind of depends on what you're facing. So there's a lot of different possibilities, and I'm hoping that this is a rough guide to help give your thinking some flow to it, kind of a little flow chart. But let's see. Let's practice a few of these things to get going. So, for example, what if I gave you a squared minus 3a minus 18? First thing to look for is a GCF. Is there a GCF in that one? No. All right. After that, count up the number of terms. It's 3 terms. All right. Is it the easy case or the hard case? Easy case. You want two numbers that multiply to negative 18 and add to negative 3. So 6 and 3 might jump out at you. One of them has to be positive. One of them has to be negative. Which one's the negative one? Negative 6. Good. The larger of these has to have this sign, and this one has to be the opposite sign so that you get a negative product. Good job. Let's try another one. X squared minus 36. Well, two terms. They're squared terms. It's the difference of squared terms. So, x minus 6, x plus 6. That's the difference of squares. What if I had x squared plus 36? Yeah. The nice difference that makes is that this one is prime. Sum of squares is prime. Let's kind of keep going with two terms here. What if I gave you 4x squared minus 36? How would you handle that one? I think I heard one voice. Thank you, Andrew. Factor out the 4 first, all right? It makes your life a lot easier, and you're actually going to get the problem completely correct. So if I factor out the 4, that leaves behind what? X squared minus 9. Leave the 4 out in front and continue to factor. X squared minus 9. Thank you. X minus 3 and x plus 3. If you wrote x plus 3 and x minus 3, that's fine as long as you have one of each there. So looking good. What about x cubed plus 8? Where does that put us on the scheme of things? Nice. Sum of cubes, right? So you've got two terms, and they're cubed, So it brings you down here, and it's the sum, so you have the sum of cubes. Now, students of mine from last semester might remember this, but here's the formula, and I'll go through this formula, but one of the things that helps out is to know the signs. How do you tell the signs here? What's my little trick for knowing the signs? SOAP. Same, opposite, always positive. George, did some instructor that you had teach you that one too? All right, see, great minds think alike. Good deal. So SOAP, this is going to be the sum of cubes. What it is not is x plus 2 cubed. If you write that, I'll thank you in advance for making it very easy for me to grade, if you know what I mean. All right. So the sum of cubes, or the difference of cubes, is always going to be a binomial times a trinomial. We're going to start out in the binomial with what do I cube to get each of these terms? X and a 2. Now from there, it's a matter of, okay, well, let's take this term and multiply it by itself. X times x gives me x squared. I'll do the same thing with a 2. 2 times 2 is 4. To get that middle term, I need to do something else with these two terms. X times 2, or 2x. And here's where that SOAP part comes in. Same, opposite, and always positive. So, Megan, what signs should I put in here? Plus, minus, plus. Yay. Thank you. So overall, here's your answer. Let's try this one. 2y squared plus 7y plus 3. What are we going to do to factor this one? Well, let's see. 3 terms is going to be the easy case or the not so easy case? Not so easy case. In fact, it could look familiar. All right, so with these, there's kind of a little trick here. And let me help you out by going through this one first. The way you work these things is when you have a number here that's something other than 1, you're going to multiply the outside two numbers. So 8 times negative 15 is negative 120. And you're going to find two numbers that multiply to negative 120 and add to positive 2, the middle number. And the way you can do that is write yourself up a little table. Let's put negative 120 here. You start listing all the different numbers that multiply to negative 120. Now, generally speaking, I give you numbers that are a little bit simpler than this. Want to find out what these add to. So negative 1 and 120. Well, that adds to 119. So you keep going. Negative 2 and 60. And so on. And eventually you'll get down to 10, negative 10, and 12. And that's your winner. That one adds up to 2. So you work your way methodically down. The nice thing about this method is that if you can't find two numbers that do this, that multiply to negative 120 and add to that middle number 2, it's prime. That's it. You're done. So I like that about this method. You're going to take that middle number here and split it up. 2x. I'll split it up as 12x minus 10x. And then you can factor by grouping. You take a 4x out from those two, and you take a minus 5 out of those two. That leaves you with a GCF. 2x plus 3 is your GCF. When I factor that out, I leave behind 4x minus 5. These are not fun to factor no matter how you do them. You don't have to do them my way. If you have something else that works for you, keep using it. I'm not going to try and make you switch. Okay, so let's start using some of that factoring work. Let me grab a different problem. I didn't like the one I solved in my morning class, or my earlier morning class. Okay, let's take a look at problem number 20. So it's x squared minus x minus 12 over x squared plus 5x plus 6. Now the thing to do when you're working with these types of problems is to factor them first. Each term in the numerator and denominator is joined to the other terms in the numerator and denominator. In fact, the whole things are joined. You can't cancel into this. You can't, for instance, cancel out the x squareds or cancel the x or the 6 into the 12. It doesn't work that way. What you can do is factor. And both of these are the nice case of the trinomial. The numerator one I think we already looked at. It's x minus 4 times x plus 3. But how about the denominator? Both of them have to be a plus. Two things that multiply to 5 and add to 6. Oh, multiply to 6 and add to 5. Thank you. So, yeah, 3 and 2 or 2 and 3. Either way you want to write it. And then the good news is that here you can actually cancel. The x plus 3's cancel. And that leaves you with your final answer of x minus 4 over x plus 2. And that's it. That's as far as you can go. Please don't cancel the x's. I know it's tempting, but we can't. We're going to leave it like this. If I remember my morning class, when they did their factorization, something like this, there was nothing common between the numerator and denominator. So that's it. That's as far as you could go. And that one was in lowest terms. So, okay, that can happen. Just kind of a heads up on that. Let's keep going, though. Problem number 24. 1 minus x squared over x cubed minus 1. Now let me do something with the numerator just because it's going to make it easier on us in the end. Because I want to switch this one around. So, in fact, let me do this kind of off to the side a little bit. This 1 minus x squared, I want to kind of flip it around. But I can't just do that. What I can do is I can factor out a negative 1. And if I do that, it's going to change the sign on both of these terms. So I'm just working with that numerator at the moment. Now when you add things, you can add them in either direction. Recall 7 plus 8 equals 8 plus 7. And so I can switch the order in which I'm adding these things. That's negative of x squared plus negative 1. And last but not least, instead of x squared plus negative 1, I'll write that as x squared minus 1. Now there was a student in my morning class that didn't kind of understand this, so that's why I went through this with you. But what you should realize and do is not necessarily all these steps, but just jump from here to here. And that hopefully is going to make this a little easier to work with. By the way, there's nothing wrong with asking questions. I appreciate questions. So it was helpful this morning that he was asking some questions. This puts it in a form that we can work with a lot friendlier. Let's take a look at the numerator. Any ideas on how that one's going to factor? Yeah, x minus 1, x plus 1. We've already done that one today. What's our trick in the denominator? Yeah, a binomial and a trinomial, right? This is the difference of cubes. So an x and a 1. See if you can't remember how to do this. You take the first one and multiply it by itself. Take the second one and multiply it by itself. That gives you the outside terms. And the product of the two is going to give you the inside term. Looking good. Demetrius, what signs go in here, please? Good. Same sign. Opposite signs, always positive. Nice. So we've done a lot of work here, a lot of nice work. But what's that give us? What can we do now? Yeah. Hasta la vista, baby. Those are gone. Cancel those things. So what you're left with, did the negative disappear? No. You can leave that factored. Negative of x plus 1 over x squared plus x plus 1. So, cool. That's your final answer. You can distribute the negative if you want. I don't care. All I want to make sure is that you do that cancellation of the x minus 1. That's my big concern on this one. Looking good on that one? Yes? Yeah? All right. Thank you. We're going to jump to a much lengthier problem. And look at this one. Anything else on problem 24 before I move to another example? Okay. 4y squared minus 9 over 2y squared plus 9y minus 18 divided by 2y squared plus y minus 3 over y squared plus 5y minus 6. Wow, a lot going on here. But one thing that's going on that you need to pay attention to the most is that it's a division here. Right? You're dividing these two things. How do you handle division? Thank you. So you multiply by the second fraction. Thank you, Maha. So it's going to be 4y squared minus 9 over 2y squared plus 9y minus 18 times y squared plus 5y minus 6 over 2y squared plus y minus 3. Now, if you're really good, you could start the factorization at this point too. But in terms of factorization, let's go for the low-hanging fruit first, the easy picking stuff. The numerators of these two. Yeah. How about, yes, yeah, I like that. Me, yes, you. How about the first one here? Any idea how this would factor? Well, let's see. All right. So it's two terms, right? Let's work down our little list here. There's no GCF. It's two terms. Are they squares or cubes? Squares, so that brings us down here. And we've got a difference, so it's a difference of squares. What do you square to get this one? 2y, and then a 3. 2y minus 3, and 2y plus 3. How about this one over here? Well, we got 3 terms. Then what? Somebody said it. Y plus 6, y minus 1. 2 terms that multiply to negative 6 and add to 5 are 6 and negative 1. Good deal. Now, in the interest of time, I'll give you this one here on the denominator. This one factors as 2y plus 3. Thank you. And y minus 1. We still have this one left to factor. And that one's kind of the annoying one because it's the difference of the squares in the not-so-nice case. In the not-so-nice case, at least the way I teach it, we'd multiply the outside terms. 2 times negative 18 gives you negative 36. So I want to find 2 numbers that multiply to negative 36. What do they have to add to? 9. So, let's see. Negative 1 and 36. Negative 2 and 18. Negative 3 and 12. Negative 4 and 9. And negative 6 and 6. So those are all the pairs of numbers that multiply to negative 36. But they're supposed to add to 9, which is what this middle pair does. If you can get those 2 numbers, the rest of the problem, I'm hoping, is not going to be that bad. Let's carefully dissect what happens next. I'm going to split this up using those 2 numbers. So it's going to be 2y squared, and then let's put in plus 12y minus 3y. So that middle term here is being split up using these 2 numbers here. And the order that you choose doesn't matter. I chose this out of convenience. But now I've got 4 terms here. Does anyone remember how to factor something that has 4 terms? What should I use? Grouping. Yeah. 4 terms, factor by grouping. So we can factor out the first pair, and from the second pair, so what's in common to the first pair? 2y, thank you. Leaving behind y plus 6. And then minus 3 times y plus 6. That's good news. These terms match, and they should. If they didn't match, we'd have a problem. All right, but they match. So we can complete the factorization as y plus 6 times what's left? 2y minus 3. Yay. Two y minus 3 times 2y plus 3, y plus 6 times y minus 6, y plus 6 times y minus 1, 2y plus 3 times y minus 1. Gee, I didn't leave myself much room to write the answer, but I'm not sure it's going to matter. Whew. Time for the mother of all cancellations, right? What do you see that can cancel? 2y plus 3, that can cancel. Y minus... Oh, did yeah, it should be 2y minus 3. I'm not sure what I was copying here. 2y minus 3. There we go. That looks better. So that's going to help us out as well. The y plus 6 cancels. And now that I fixed that, y minus 3 is going to cancel. So let's get rid of those. And wow, isn't that special? These cancel as well. So what's that leave me with? 1. Whew. Wow. A lot of work on that one. It all cancels out. 1. Yeah. Don't worry. I promise not to put more than 18 or 20 of these on the exam. Okay? Okay. Remember, you're supposed to laugh and make me look good while we do this? All right, all right. All right, good deal. I know it's first day. It's first day, so we'll cut you some slack. All right. A lot of work on this one. If there's something, Farah, that you need me to wrap up with or answer, let me know. Yes? This one? 2y minus 3. Yeah, I miscopied that. So that comes from here, and it was the factorization of this one here in the denominator. So, nice. Is that Mike Volbach screaming in the background someplace? Sounded like it.
No, it's not him. I don't think. Oh, maybe.
It sounded like him. Yeah.
It's been 3 weeks.
Yeah. He was in here that class this morning, so. Okay, good on this one. Last chance, going once, twice, sold to the A student. Well done. Let's move on to adding and subtracting fractions. And actually, the couple examples that we're going to work with are going to be subtraction. Let's start out with problem number 44. X over x minus 4 minus 3 over x plus 6. Can I just subtract these two? Get, say, x minus 3 over, I don't know, negative 4 plus 6? Yeah, Majnun. All right. No, the answer is no. You can't. What do we need before we subtract these things? Common denominator. Good. So you need a common denominator. Let's see if we can't get one. Common denominator comes from looking at these things as whole terms. You can't say, oh, gee, common denominator between 4 and 6 is 12. It doesn't work that way. Our LCD is x minus 4 times x plus 6. It's the whole thing. So in looking at the common denominator, what do I have, or what am I missing here that I have here? X plus 6. So let's multiply by x plus 6 over x plus 6. And likewise over here, I'm missing the x minus 4 term. So I got x minus 4 over x minus 4. Okay. In each of these, let's distribute. Now I'm not going to worry about the negative just yet. In the denominator, well, let's see, let's do the numerator first. That's going to be x squared plus 6x, and then 3x minus 12. Now as far as the denominator is concerned, I'll give you a little option. Sometimes I use it. The denominator is going to have x plus 6 times x minus 4, right? But that's my LCD. So sometimes I get lazy. Just write LCD. Or you could write x minus 4 times x plus 6. It doesn't matter to me. When it's all said and done, I do want the denominator written out. But now, because these denominators are the same, I can combine these two into one whole fraction, LCD. But unless I'm careful, then I might make a mistake. What's the mistake here? Good. Should be plus 12. And to see that, what you could do is realize that there's parentheses around this, and that negative has to distribute itself. Now, if we distribute that negative, then we end up with x squared plus 6x minus 3x plus 12 over the LCD. Is there anything else I can do? Yeah, combine like terms. X squared plus 3x plus 12. For your final answer, please do not write LCD. I want to see it out. So x minus 4 times x plus 6. This numerator doesn't factor, so that's it. We're done. How's that one looking? Okay? Yes? If there's something that, thank you, George, something about this that maybe I went over a little bit fast, let me know. Be glad to help you out. Please, yeah.
We definitely don't multiply out the denominator, right?
You don't have to. In fact, I encourage you to leave it factored, because if the numerator factored, then you might get some additional cancellation with the denominator. So suppose instead of this for the numerator that I had x squared minus x minus 12, x minus 4 over x plus 6, you might realize that, oh, gee, the numerator factors like this. And having it factored, I see that, oh, I can cancel there. So it's
Weird that it was factored at the bottom.
yeah, it's just, I guess one way to view it is I'm allowing you to be lazy. I'm not making you multiply it together. You could, if you wanted to, x squared plus 3x plus 12 over x squared plus 2x minus 24. So you could do it that way. That's fine. If that makes you feel better, knock yourself out. I mean, no, it's whatever. No, I appreciate what you're saying. It looks weird to have it one way factored and the other way not factored. But do you see? Yeah, they're both fine. I have no preference for one. Okay, let's do one last one like this. And that'd be problem number, I think it's 56, but I could have my number wrong on that. X over x squared minus x minus 6 minus 1 over x plus 2 minus 2 over x minus 3 Okay, so we need to determine what the LCD is here. Oh, brilliant. Who said that? Well done. Yeah, in order to determine what the LCD is, it's helpful to factor this. So how does that term factor there? Perfect. X minus 3, x plus 2. Yeah. There we go. And that hopefully makes it a little bit more clear what the LCD is. Ashani, what would the LCD be for us, please? Yeah, x minus 3, x plus 2. Nice. And the good news for us is that we already have the LCD here, right? We don't have to do anything for that first term. We do for the second term. Carol, what's missing here that I have as part of my LCD? Good, x minus 3. So let me kind of squeeze that in here as x minus 3, x minus 3. And over here, I'm missing the x plus 2 and x plus 2. Nice, Carol. So where does that leave me? I've got x over the LCD minus x minus 3 over the LCD, because 1 times that is still just going to be x minus 3, minus, let's distribute the 2. 2 times x is 2x plus 4 over the LCD. One of the things I like about this example is it's going to ask you again to be careful with distributing those negative signs. It might be helpful to you to put parentheses around those terms in the numerator. Let's write it all with one long fraction, x minus 3 minus parentheses 2x plus 4 all over the LCD, and clean that up. Those negative signs have to distribute, and you want to combine like terms. So, why don't you do that? See what you can come up with. So the thing here is to distribute the negative sign to both terms in the numerator for these two fractions. And then when we combine like terms, what are we left with in the numerator? What's left? Good. Negative 2x minus 1. In the denominator, I'd like you to go back and write down x minus 3 times x plus 2. I'm not really happy about seeing LCD here when it's all said and done. All right. Is it okay to write LCD through there? Does it bother you, or do you like to see out? Yes, no preference. All right, so we'll get away with that for now. How are we looking on that one? All right. Let's see. I think that's about all I want to say for this section here. So unless there's some questions, let me assign some homework from this section. When I assign homework, it's just going to be the odd problems. So for homework, this is section 1.6. Try 7 through 35, 39 through 57, and that's on page 42 to 43. 1.4, I'm sorry, I'm thinking of the next section. And that's just the odds. Whew. Cool, all set.